When you look at the seas and oceans on a map, you might think that they just flow into each other. Like there's really only one big ocean and people just arbitrarily gave different names to its different parts. Well, guess what? You'll be amazed at how much more substantial the borders between them actually are. For example, the border between the Pacific and Atlantic Oceans is like a literal line between two different worlds. It looks like the two oceans meet at an invisible wall, which does not let them flow into each other and mix their waters. Why on earth does that happen? Obviously, there's no actual invisible wall inside, and water is just water. So what could be interfering with its mixing? Well, the thing is that water isn't just water. There can be different kinds. The Atlantic and the Pacific Oceans have different densities and chemical makeups, the level of salinity, and other qualities. One can see by their color that they are far from the same. Borders like this, between two bodies of water with different physical and biological characteristics, are known as haloclines. Jacques-Yves Cousteau discovered one of them while he was deep diving in the Strait of Gibraltar. The layers of water with different salinity looked like they were divided with a transparent film, and each layer had its own distinct flora and fauna. Haloclines appear when water in one ocean or sea is at least 5 times saltier than in the other. You can create a halocline at home if you pour some seawater or colored salty water in a glass and then add some fresh water on top of it. The only difference is that your halocline will be horizontal and ocean haloclines are vertical. For those of you who were paying attention in chemistry class, you might remember that if you have two liquids with different densities in one space, the denser liquid should eventually end up below the less dense one. By that logic, the border between the two oceans should look not like a vertical line but a horizontal one, and the difference between their salinity would become less obvious the closer they got to each other. So why doesn't it work like that? Firstly, the difference in density of the two oceans is not big enough for one of them to sink down and the other one to rise up, but it is big enough to not let them mix. Another reason is inertia. There's an inertial force known as the Coriolis force, which influences objects when they are moving in a system of axes, which in turn are moving as well. In simpler terms, the Earth is moving, and all the moving objects on it are carried along, acted upon by this Coriolis force, deviating slightly from their natural course. As a result, the objects on the Earth's surface don't move straight on, but deviate in a curve, clockwise in the northern hemisphere and counterclockwise in the southern. But because the Earth is moving slowly, after all, it does take the planet a whole day to make a full circle around its axis, the Coriolis effect isn't easy to observe in the short term. It becomes easier to notice only in long-term intervals, like with cyclones or ocean flows. And this is why the direction of flows in the Atlantic and the Pacific Oceans is different. This difference also doesn't let them mix. Another important difference between these two ocean waters is the strength of molecule connection, or surface tensile strength. Thanks to this strength, molecules of the same kind hold on to each other. The two oceans have totally different surface tensile strengths, which also doesn't let them mix. Maybe if the waters were completely still, they could gradually start mixing over time, but as they flow in opposite directions, they just don't have time to do this. We think that it's just water in both oceans, but its separate molecules meet for just a very short moment and then get carried away with the ocean flow. But if you think that it's only the Atlantic and Pacific Oceans that don't get along with each other, you are sorely mistaken. There's lots of places on the planet where the waters of the two seas or rivers don't mix, and for even more weird reasons. For example, there's a different kind of border called a thermocline. These are borders between waters of different temperatures, like between the warm water of the Gulf Stream and the much colder North Atlantic Ocean. But the most interesting kinds are called chemoclines. These are borders between waters having different microclimate and chemical makeup. The Sargasso Sea is the biggest and most widely known chemocline. It is a sea within the Atlantic Ocean, which has no shores, but is very obviously distinct. You can't not notice it. Let's now take a look at some other spectacular clines we have on planet Earth. And just as a heads up, I might mispronounce some of these names coming up, so please forgive me. First up, we have the North and Baltic Seas. These two seas meet near the Danish city of Skagen, The water in them doesn't mix because of different densities. Sometimes you can see the waves of the two seas clash into each other, making foam. Their waters do mix very, very gradually. That's why the Baltic Sea is slightly saline. If there had been no water coming to it from the North Sea, it would have just been a freshwater lake. Next up, the Mediterranean Sea and the Atlantic Ocean. They meet at the Strait of Gibraltar and have both a different density and salinity. So there's two reasons their waters don't mix. Then we have the Caribbean Sea and Atlantic Ocean. The place where they meet is near the Antilles, and it's very easy to spot. It looks like someone has painted water with two different shades of blue. Another place where these two meet is Eleuthera Island of the Bahamas. The Caribbean Sea water is turquoise, and the Atlantic Ocean water is dark blue. There is also the Suriname River and the Atlantic Ocean, which meet near Paramaribo in South America. How about the Uruguay River and its afflux? These two meet in Misiones province in Argentina. One of them is claimed to be used in agriculture, and the other has an almost red tint to it because of loam during rainy seasons. Here's an interesting one. The Rio Negro and the Solimões rivers, part of the Amazon River. 6 miles from Manaus in Brazil, the Rio Negro and Solimões rivers flow into each other, but don't mix for about 2.5 miles. The Rio Negro is dark and the Solimões is light. They have different temperatures and speeds of flow. Then there's the Moselle and Rhine rivers, which meet in Koblenz, Germany. The water in the Rhine is lighter than that of the Moselle. Okay, how about 3 different bodies, like the Ilz, Danube, and Inn rivers? The junction of these 3 rivers is in Passau, Germany. The Ilz is a small mountain river to the left, the Danube is in the middle, and the Inn is a light river to the right. The Inn is wider than the Danube here, but is still its afflux. Take a look at the Alaknanda and Bhagirathi rivers, which meet in India. Alaknanda is dark and Bhagirathi is light. I really hope I got those right. The Irtysh and Ulba rivers flow into each other in Kazakhstan, near the city whose name is Ust-Kamenogorsk. The Irtysh has clean water, and the Ulba's water is cloudy. Moving further east, the Jialing and Yangtze rivers meet in Chongqing, China. I really hope that's close at least. The Jialing is clean and the Yangtze is brown. The Irtysh River actually has another intersection with the Om River. These two rivers flow into each other in Omsk, Russia. Here, the Irtysh is cloudy and the Om is pure and transparent. Speaking of Russia, the Chuya and Katun rivers meet in the Altai Republic. The water of the Chuya has an unusual cloudy white color here and looks dense and thick. The Katun, by contrast, is clean and turquoise. Flowing into each other, they form a single 2-colored stream that does not mix for some time. On the other side of the globe, we have the Green and Colorado rivers. The place of their junction is National Park Canyonlands in Utah, USA. The Colorado River is brown and the Green is, well, green. The corridors of these rivers go through rocks with different chemical makeup. That's why they have such a big contrast of colors. Last but not least, we have the Rhone and Arve rivers. They flow into each other in Geneva, Switzerland. The Rhone is a pure river that flows out from the lakes of Geneva, while the Arve is cloudy and gets its water from the glaciers of the Chamonix Valley. This is by no means an exhaustive list of all the strange climes on our beautiful planet, but as you can see, it happens a lot more often than you think. These are the kinds of environmental oddities that can really teach you about the way the natural world works. If you're curious enough, of course. Thanks for watching. Oh, and let me know how well I did with the pronunciations. Constructive feedback is always helpful.
Okay, let's try something together. Open any world map you have available. It can be the one you find in your bookcase or even an online version. Take a look at the vast area covered by water. That's 71% of the Earth's surface. And all of that is salt water from the world's oceans. There aren't any borders between the 4 oceans we've all come to know. But oceanographers and the world's countries did traditionally split these waters into 4 distinct regions: the Pacific, Atlantic, Indian, and Arctic Oceans. And here comes the big surprise. The scientific community has recently recognized the 5th body of water. It's called the Southern Ocean, and 3 of the 4 original oceans border it. It circumnavigates Antarctica and the lower portion of the globe and reaches Australia and the southern portions of Africa and South America. What makes this ocean so special? How did the scientific community eventually recognize it? And more importantly, what mysterious creatures does it hide? Let's find out. The Antarctic Ocean, or the Southern Ocean, was first mentioned back in 1937 in the second edition of the International Hydrographic Organization's Limits of Oceans and Seas. That's a mouthful. Back then, this organization considered that it was wrong to consider the Antarctic Ocean as its own distinct body of water. Why? Well, because at that time, an ocean was defined as water surrounded by land and not water surrounding land. However, they reconsidered it in 2000 and voted to include this ocean in the official list. They also decided on the name Southern Ocean over the commonly used Antarctic Ocean. Finally, the organization concluded that the ocean should be considered as ending at the 60th parallel south latitude. But how old is this ocean? Well, many specialists believe it to have formed only 30 million years ago, which would make it the youngest of the world's oceans. It was created when Antarctica and South America moved away from each other during the early stages of our planet's development. This unique water current is a distinctive component of the Southern Ocean, as it helps keep the waters flowing around the icy continent. It's called the Antarctic Circumpolar Current, and it moves to the east with incredible speed. It's estimated that it moves an enormous amount of water per second. Some of the disputes regarding the Southern Ocean also have to do with this amazing current. Some specialists believe it separates the water of the Southern Ocean from the waters of the nearing Atlantic or Pacific. Only the rapid circulating water is considered the Southern Ocean. On the other hand, though, a handful of scientists say that the current actually makes the naming issue more complex by not limiting the waters to a specific geographic location. They believe that the waters in the current are different in terms of composition from waters in the northern oceans because they are way colder and have a lot more salt. Sailors don't really like this new body of water, mostly because of the frequent cyclone-like storms that it experiences. They happen because of the big temperature difference between the ice packs and the ocean waves. As a result, these storms are very difficult to surpass for any sailors that happen to encounter them. I mean, really, these are the strongest winds found anywhere on our planet. More so, the vessels going through this area must also be wary of the frequent icebergs that may pop up every now and then, and also of the low surface temperatures. Just to paint you a better picture, some of the icebergs found here can span over several hundred meters and can exist all year round, regardless of the season. The latitudes from 50 to 70 have even earned the nicknames of Furious 50s or the Shrieking 60s because of these intense year-round storms. Even the landscape is unique. They say the Southern Ocean has bluer glaciers, colder air, and more intimidating mountains than anywhere else in the world. Now, let's get to the mysterious creatures that call this place home, as thousands of species of wildlife live only here and nowhere else in the world. Let's start with the quirky sea pig, or one of the sea cucumbers as it's sometimes called. There are a lot of them in the waters off Antarctica. Why is it called that way, though? Because of its pink hue and round, bloated looks. On a closer look, it even appears to have a little tail and set of ears, just like a pig. They do help a lot with the quality of the waters here, filtering sand and sediment. Then there are the Hoff crabs that live on the floor of the Antarctic Sea. The Southern Ocean is a cold water environment, but crabs are more adapted to warmer waters. So, Hoff crabs gather around the warmth made by volcanic vents. They get the needed warmth and food here. You can find them in large piles, one on top of another, literally filling the space at the vent openings. Now, wonder how they got their unofficial name? Well, it's because of their apparent similarity to the actor David Hasselhoff, whose impressive chest reminded explorers of the crab. Okay. Ever seen a fish that's completely transparent? You'd have to get to these waters down in the south, but they do exist, and they are simply called the ice fish. You can basically see inside them, being completely clear and all. That's because of their see-through skin and because they don't have any red blood cells. Their special power is that they can use antifreeze to prevent their bodies from going solid in the cold waters of the Southern Ocean. Instead of the standard thicker blood, the red one with hemoglobin, ice fish have thinner blood that moves around more easily throughout their bodies, hence giving them the much-needed nutrients and oxygen. Now, is there a monster hidden in these waters? Some people believe this to be the case, and thanks to recent research, we even have video footage of it. Some Australian researchers stumbled upon a bunch of weird-looking creatures that were swimming near the seafloor of the Southern Ocean. This pink blob-like fish seemed to be propelled by a little pair of fins. To quote them on it, it seemed to resemble a chicken just before you put it in the oven. I'm not sure I even want to know what that looks like. It took them some time and research to identify the monster. It's a shy species of sea cucumber, known more by its creative nickname, the headless chicken monster. We've known this creature has existed since the late 1800s, but we've barely ever seen it. And we've only ever captured it on tape once before when it was spotted in the Gulf of Mexico, which is quite far from the waters off the coast of East Antarctica. There's so much we don't know about this creature, like how many of them exist in our waters and how they live, eat, and reproduce. Ever heard of the emperor penguin? It's not a penguin species that just happens to have a crown on its head, if that's what you're thinking. But they are one of those penguins that inhabit this specific location and are also the largest species of their kind altogether. What makes them special is that they make their colonies on the sea ice, and most of them never step foot on land. More so, penguin dads lose almost half their weight while incubating the eggs. They're also fascinating swimmers, able to dive deeper and longer than any other bird, up to 700 feet. Not to mention they can stay submerged for up to 18 minutes at a time as they gather food. We have yet to uncover all the secrets of the mysterious Southern Ocean, but it's clear that it's home to some unique and fragile marine ecosystems. Recognizing it as a new ocean could be one way to focus the public attention on it and help its conservation.
The Empire State Building's tower was designed to serve as a docking station for dirigibles. At that time, people believed that these airships would become the main means of transportation in the future. The project included gangplanks, check-in and customs offices, and so on. But then the engineers realized that the wind up there was too strong for their plans, and they gave up on their idea. Angel Falls, the largest uninterrupted waterfall on the planet, is more than twice as tall as the Empire State Building. During the dry season, the falling water sometimes evaporates before it reaches the ground. One of the most mysterious sounds ever heard on Earth was the bloop. It occurred in 1997 and resembled the noise of marine animals, but the volume was too great for a sound produced by a living creature. The bloop continued for 1 minute. It started from a low rumble and then rose in frequency. Antarctica might just look like a giant field of ice, but there's actually a huge continent underneath. That means that it has volcanoes, mountains, and valleys, like any other continent. Scientists have recently discovered that the Antarctic landmass has the lowest point on the planet, as well as huge mountain ranges. If any of the numerous volcanoes were to erupt, it would melt a huge part of the surface ice and increase the spill of ice into the ocean. The sea level would rise and flood coastal areas around the world. The ocean waters would also be disrupted, putting marine life at risk, though all of these volcanoes are dormant at the moment. Each day on the South Pole lasts 6 months on this continent. The South Pole only has a single sunset and sunrise across an entire year. Early Earth might have been purple, not green. There's a theory that ancient microbes used molecules rather than chlorophyll to absorb sunlight. These molecules likely gave living organisms a violet tint. During the Stone Age, the entire population of Central Europe was around 1,500 people, which means they would all fit on a mid-sized cruise liner these days. Astronomers have figured out that the Milky Way weighs around 1.5 trillion solar masses, and one solar mass is the mass of our Sun. A tiny part of this weight is a supermassive black hole at the center of the galaxy, and 200 billion stars. The rest is dark matter, mysterious and invisible. If all sheets of Arctic ice and glaciers melted at the same time, the sea level would rise for the height of a 26-story building. Under black or UV light, ripening bananas look bright blue. That's because of the chlorophyll that's breaking down when the fruit is ripening. Because of tectonic plate movements, the Pacific Ocean shrinks every year, and the Atlantic Ocean gets bigger by the same amount. These days, there are only 2 ice sheets in the world left after the planet's last ice age. The first is the Greenland ice sheet. The second, the Antarctic ice sheet, is enormous. It's the size of Mexico and the continental US combined. Tsunami waves often go unnoticed. They don't rise for more than several inches above the surface until they reach shallow waters. When the ocean is deep, though, they can travel as fast as a long-distance passenger airplane. Corals that live in shallow waters produce their own protection from the sun. Without it, sunlight would harm the algae living inside them. To protect these algae, which are the main source of food for the corals, they fluoresce. This process makes proteins that act as sunscreen. Almost 90% of the volcanic activity on Earth happens in the oceans. The South Pacific has the largest concentration of volcanoes people know about. There's one volcano cluster that has 1,133 volcanic cones. All of them are active and cooped up in an area the size of New York State. The Zemchug Canyon in the middle of the Bering Sea is the largest underwater canyon ever discovered. There are more treasures and artifacts at the bottom of the ocean than in all museums in the world combined. In 1900, one of the biggest hurricanes struck near Central America and in the Gulf of Mexico. It then went as far as Florida and Texas and is considered to be the most devastating hurricane in the United States history. They first detected it on August 27th, and it lasted for many days. By the time it reached the Texas coast, the storm had turned into a Category 4 hurricane. Hurricanes are categorized on wind speed and intensity using something called a Saffir-Simpson scale. There are 5 different categories from 1 to 5, with 1 being the weakest and 5 being the strongest. The people of Galveston had less than 4 days to prepare for the arriving storm that even stretched out to Oklahoma and Kansas. The Great Hurricane then made its way to the Great Plains and turned towards the Great Lakes, New England, and reached southeastern Canada. The storm was so bad that more than 3,600 homes were damaged, even though they were sturdy enough to withstand the storm. Given the population numbers back then, it was equivalent to hundreds of thousands of houses destroyed, if not millions. Spotted Lake, Canada. They call it the most magical spot in Canada. In winter and spring, this is just a regular lake that looks like any other, but try going there in the summer when the water starts to evaporate. It'll feel as if you've entered a different world, a polka-dotted landscape with blue, green, and yellow spots. Over the summer, there are over 300 pools there, and they all look magical. Over the centuries, people believed each of them had different healing properties. Oh, and the explanation for the vibrant colors is pure science. Each of them has a high concentration of different minerals. We live inside the sun. Its atmosphere stretches far beyond its visible surface, and even though Earth is 93 million miles away from the star, it's still within reach of the sun's atmosphere. Auroras happen when charged particles from the sun get caught by Earth's magnetic field and crash into the upper atmosphere near the poles. Our planet is gradually slowing down the speed of its rotation. It happens at an unhurried pace of 17 milliseconds per 100 years. Because of this, our days are becoming longer, and still, only after 140 million years, a day on Earth will last 25 hours. Earth's southernmost continent, Antarctica, is only the 5th largest one, but it contains almost 70% of the planet's fresh water and 90% of the world's ice. Antarctica is also considered to be a desert. Lots of rocks on Earth have a Martian origin. Scientists analyze the chemical content of some meteorites found in the Sahara Desert, Antarctica, and other places. It turned out that these rocks had arrived from the Red Planet. The largest sandcastle in the world is located in Denmark. 30 sand sculptors who created it used more than 5,000 tons of sand. To make it more durable, they added 10% of clay, together with a layer of glue. They built it to stand tall against long and stormy winters. Some photons that don't get absorbed are re-emitted, and their wavelength determines the color we see. When you expose a material to sunlight or photons of higher energy, it can damage its chromophores, which is why they won't be able to emit photons at certain wavelengths. Red materials fade in sunlight the most. Their chromophores emit red light in a way they mop up photons of the rest of the wavelengths. From 60 to 100 tons of space dust drift down to our planet's surface every day. These tiny cosmic particles are mostly released by comets, which are usually made of dust and ice. When the sun turns this ice into vapor, the remaining dust travels down to Earth.
The ocean is one of the most incredible places on Earth. It's not only beautiful, but also dangerous. We all know about sharks, huge octopuses, heavy storms, and the Bermuda Triangle. But there's something more terrifying and more dangerous than all of these things. I'm talking about rogue waves. The 4-passenger yacht Mignonette is sailing through the Cape of Good Hope in southern Africa. A storm blows through, but the yacht successfully survives it. By evening, the wind has completely subsided. The sea is calm. The team, tired after the storm, is going to rest. At this moment, seemingly out of nowhere, a 39-foot wave appears and crashes over the yacht with terrifying force. The yacht succumbs and sinks. Thankfully, the passengers escape in a lifeboat. For the next 24 days, they drift on the open sea until they're picked up by a passing ship. No one believed the stories of the surviving passengers about a huge wave. This story isn't a plot from a thriller movie, but a real event that occurred on July 5, 1884. Now imagine that you're sailing on a modern yacht in the open sea. The sun is shining brightly. There's not a single cloud. The sea is crystal clear and calm. What could be better than a vacation like this? Suddenly, you hear a very loud hum. In 2 to 3 seconds, a huge 33-foot wave appears from the calm surface of the sea and crashes into your yacht. Fortunately, the ship manages to stay afloat, and the wave disappears as suddenly as it appeared. This is also a real case that happened to the owner of the Calaran yacht on June 17, 2018. These waves have different names: white, rogue, wandering, monster. The French call them a bad joke. Unfortunately, there's nothing to laugh at. A meeting with such a wave usually ends with a sunken ship. Sirens, sea monsters, the anger of Poseidon – this is how people explain the appearance of massive waves in ancient times. Christopher Columbus was the first to write a note about a rogue wave as a natural phenomenon. In August 1498, his team explored the shores of West India, later America, when suddenly all of the crew members heard a deafening roar, and then a towering 88-foot wave appeared out of nowhere. Fortunately, the wave passed by, and Columbus went on his way. After that, a lot of reports were recorded about this phenomenon, but no one believed the sailors. Mermaids, kraken, and now monster waves? Come on, guys! This is the typical reaction to anyone claiming to have witnessed the nightmarish waves. Even when a 74-foot rogue wave suddenly fell on the British liner Queen Mary in 1942, the 15,000 people who lived to tell the tale were rarely taken seriously. Only in 1995 was the rogue wave officially recorded with special instruments. That day, an 85-foot wave hit the Norwegian gas platform Doppner. In order to study the nature of these waves, in 2000, the European Union created an international project called Max Wave. As part of this project, scientists launched 2 satellites to monitor the world's oceans. However, they ended up with more questions than answers. There's a special wave theory, according to which the larger the wave, the less likely it is to occur. Max Wave satellites managed to record waves up to 82 feet. But here's the most interesting part. Such a wave should only appear every 200 years. but satellites discovered 10 monster waves in the first 3 weeks of operation. 19 years have passed since then, and we still know very little about it. The worst thing is that scientists have no ideas about how to predict the appearance of these waves in advance. Modern radars and sonars have recorded the proportions of these waves. Their height reaches from 39 to 164 feet. Their speed can reach 62 miles per hour, and their life expectancy is from 20 seconds to 2 minutes. Although information is scarce, scientists have managed to divide these waves into 3 types. The first type is the classic white wave. It appears not only in a storm, but also in a calm sea. After an unexpected appearance, it also suddenly dissolves into the water and leaves no residue. The second type is Three Sisters, and you guessed it, these are 3 consecutive waves, one of which is more massive than the others. Even a huge supertanker could break under the weight if caught in such waves. The third type is Wave Monster. Of all 3 types, this wave is the most dangerous and unpredictable. Imagine a 15-story building. The spectacle is certainly amazing, but I wouldn't want to see it in real life. Anyway, you can watch a lot of videos with rogue waves on YouTube, but after you watch our video. But what provokes these lonely waves? No one knows for sure. Perhaps rogue waves are of the same nature as tsunamis? Well, not at all. Tsunamis occur as a result of underwater earthquakes and grow as they draw closer to the coast. Some believe that they appear when the surface sea current encounters a strong headwind. Others are sure that the waves are born from the collision of warm and cold currents. Still others are convinced that it happens because of gravitational anomalies, when gravity sharply decreases or increases. There's also the theory of wave interference, small waves combining to form one big one, just like a snowball. But the most interesting theory is that waves form due to kinetic vampirism. Insert Dracula joke here. According to this version, under certain natural conditions, waves acquire the ability to exchange kinetic energy. And among all the waves, there will be one vampire wave, which will absorb the energy of the others. After accumulating enough energy, the vampire wave splashes it out. This theory explains the impact force and its sudden disappearance. Some oceanographers believe that rogue waves are to blame for the disappearance of ships in the most mysterious place in the Atlantic Ocean, the Bermuda Triangle. And while it's likely that rogue waves periodically appear there, it's impossible to consider them the main solution to the mysteries of the triangle. Besides ships, planes disappear there, and it's unlikely that the waves can reach them. Adding even more mystery to the phenomenon, these waves appear not only in the seas and oceans, but also in lakes. They were recorded numerous times in the Great Lakes. In Lake Superior, the largest of all the Great Lakes, the appearance of the Three Sisters has been recorded several times. In addition to rogue waves, sailors have told about a more terrible phenomenon, sea hollows. Imagine that this is a very big wave, but just the opposite. It goes under the water, forming a large dip in the sea. But unlike waves, such hollows have never been officially recorded. Rogue waves can be dangerous in a similar way by forming sea holes in the water. When the wave builds up, it draws in all the water around it, so near the base, these holes can be very deep. If the bow or stern of a ship ends up in one, the ship can instantly sink. I think the Jaws movie should be replaced by a new film, Waves. Who cares about sharks now, when at any moment a wave the size of a skyscraper could come rushing towards you? Hey, anybody remember the movie The Poseidon Adventure? That was a rogue wave that capsized the ocean liner. There are no ways to anticipate rogue waves, but you can significantly reduce the risk of meeting one. Study the history and meteorological records of the area you want to visit. Most often, rogue waves are found off the east coast of Africa in the Indian Ocean and in the North Atlantic. By the way, it was there in 1985 at the Fastnet Rock Lighthouse that the highest wave ever recorded was captured. Its height reached 157 feet. If rogue waves don't scare you and you're determined to set sail, then watch for weather changes and, most importantly, look often at the horizon. Single waves can appear in the distance, so you have a chance to evade them. And if one narrowly misses sinking your boat, well, as it goes by, be sure to wave.
A wanderer walking through a desert feels the scorching sun like never before. You can see him from afar thanks to his shining clothes. His long hoodie is covered with foil. It reflects sunlight and protects him from heat. The ground is so hot that shoe soles can melt on it. That's why the wanderer's boots are covered with heat-resistant material. A cloudless sky, barren land, and heat. But the wanderer is not in the desert. He's walking on the ocean's bottom. He doesn't know why this happened, but all the oceans on Earth dried up. It happened almost instantly, and even the greatest minds in the world don't know why. The wanderer knows only one thing. When it happened, his family was on the other side of the ocean. For several months, he's been traveling across this lifeless land, and he won't stop until he finds his family. The landscape around is spectacular. People have finally found out the secrets of the ocean depths. The seabed consists of huge mountain ranges and volcanoes. They fell asleep forever after the water had disappeared. Also, there are huge trenches leading to the unexplored depths of the planet. People had to build bridges to get over these enormous cracks in the ground. But most of the ocean floor is flat plains, boundless, lifeless, merciless. The wanderer's walking across a huge canyon. Once, it was swarming with sea life. The man puts on a gas mask, but not because of a sandstorm. Many fish and other marine inhabitants used to live in such canyons. Now, all that's left is a terrible smell. The wanderer passes by huge skeletons of whales. Among them, he notices dirty tents. People are hiding there from heat. The temperature in the area is much higher than in the Sahara Desert. One of the main functions of the ocean was to distribute heat all over the planet. The sun emits heat and radiation. The ocean absorbed this energy. Lots of currents were warm, and they carried this warmth around the world. The water got heated at the equator, then it evaporated and turned into clouds. When warm air rose, it pulled along colder air from below. This allowed the energy to be evenly distributed. In simple words, the ocean cooled hot places and brought warmth to cold ones. Now there's none of this. Every day the sun burns the equator and dries up the rest of the planet. The wanderer doesn't come close to the tents. He is carrying the most valuable treasure in the world and doesn't want people to notice him. The inhabitants of Earth are just trying to survive, and many have forgotten about such a thing as morality. Fortunately, the wanderer still remembers. The thoughts of the family help him remain a good person. Sometimes it complicates his life. Like now, for example. In the distance, he sees a young girl. She doesn't look well. There's no one around, and the wanderer decides to help her. Out of his backpack, he pulls a thing worth more than all the gold on the planet, a bottle of water. The girl takes a few sips, but instead of thanking the wanderer, she starts screaming. It's a trap. Her accomplices appear from different sides. Looters. They're gonna take everything. The wanderer runs away. He hasn't eaten for several days, and his strength is leaving him. He won't be able to keep going much longer. The marauders are closing in on him. The wanderer throws the bottle aside. His pursuers rush to the water like crazy. They forget about the man and fight one another for the bottle. The chances of the wanderer's survival have greatly decreased. He could make this bottle last at least several days. Plus, he's also lost a lot of fluid because of running. In the beginning, there was no panic because of a lack of water. The ocean dried up, but its waters were salty anyway. People still had seas, lakes, and rivers. But the problem was that the ocean was feeding them. When the ocean water evaporated, it formed clouds. These clouds moved all over the world and enriched lakes and rivers with rain. Now, there are almost no clouds. The sun started heating Earth much more. Lakes and seas dried up alarmingly quickly. At that moment, real chaos began. The sun is going down on the horizon. Sunset is near. It's not so hot anymore. The exhausted wanderer continues walking. In the distance, he notices something that makes him stop, take out a small shovel, and start digging quickly. There's no shelter around, just a flat plain. The wanderer speeds up, otherwise it might be too late. The pit is finally ready. The man jumps down and covers his head with a cloak. A few seconds later, a strong ash storm passes through the entire plain. The smallest particles of ash can penetrate through clothes and get into the lungs. The wind is so strong that it can knock anyone down. When the oceans dried up, the sun began to burn the surface of the planet. This led to massive forest fires. The flames destroyed almost all the trees. Huge clouds of carbon dioxide and ash formed. Driven by the wind, they travel the world and poison everything around. The wanderer is sitting in the pit while a terrible hurricane is sweeping over his head. He thinks of his family and slowly falls asleep. Cold wakes him up. Frosty air chills him to the bone. So it's night now. The wanderer climbs out of the pit and finds himself under bright stars. As soon as the water dried up, almost all clouds disappeared. Factories stopped working. Cars no longer emitted carbon dioxide. Thanks to this, comets and the most distant stars can be seen in the sky. The wanderer has seen them 1,000 times, but he's still not used to the breathtaking picture. It's like he's looking at the sky through a telescope. An icy gust of wind brings the wanderer back to reality. He won't survive the night if he doesn't find a warmer place. Before, nights were warmer thanks to the energy of the ocean. Now, as soon as the sun goes down, temperatures drop dramatically. The wanderer needs to move to stay warm. He starts walking faster. Soon, he notices some lights in the distance. It's probably other looters. The wanderer goes deeper into the valley. Stars and the moon illuminate his way. Unfortunately, he is running out of energy. He pulls a protein bar out of his pocket, but he needs at least a bit of water to eat it. To digest food, your body needs liquid. If the wanderer eats the bar, he'll only get thirstier. He can't walk and falls to the ground. He checks his pockets and finds a small kerosene tablet. He lights it using a matchstick. A tiny flame protects him from cold. To distract himself from thirst, the wanderer takes out an old MP3 player. He charged it during the day using the solar panels on his backpack. The man puts on headphones. Classical music calms him down. He lies on the ground next to the burning tablet. He needs to gain strength to continue his journey tomorrow. It's morning. In an hour, the sun will start burning the ground again. It's crucial to find water while he still has some time left. The wanderer inspects the territory and notices a spot where the ground is darker. In his previous life, the wanderer worked as a surveyor. He takes a few steps and touches the ground. It feels cool. There's an underground spring here. He begins to dig. The ground is getting wet. Water starts seeping out of the soil. The wanderer fills his empty bottles. Things don't look that bad anymore. It's getting a bit more difficult to breathe with each new day. In the past, phytoplankton and algae produced up to 70% of all the oxygen on the planet, but not anymore. Several days have passed. The wanderer runs out of water and food again. Fortunately, not for long. He's now walking among huge sunken ships. He sees modern aircraft carriers, liners, and even ancient pirate boats. In the distance, he spots huge mountains. The tops of these rocks are what used to be called the shore. The ocean floor is ending. The thoughts about reuniting with his family give him more strength. The man reaches the top and finds himself in the middle of a ruined city. It's empty. Where have all the people gone? Where is my family now? The wanderer asks himself. The man walks through the abandoned streets and meets an old man. He says that almost all the people who used to live here left the city and went to Antarctica. The wanderer has a new goal. He's going to get to the icy mainland no matter what. He will find his family.
Back in 2018, the biggest active underwater eruption ever happened. at least the one that we could officially record. Scientists followed earthquakes that struck the area in the western Indian Ocean off Madagascar. Between 2018 and 2021, over 11,000 earthquakes struck a small island called Mayan between Madagascar and Mozambique. The strongest one had a magnitude of 5.9. Until then, this area had been pretty peaceful. There had only been 2 earthquakes recorded over 50 years. Along with regular earthquakes, there were also some unusual seismic hums, like earthquakes at pretty low frequencies, forming deep underground. People couldn't feel those hums at the surface, but researchers around the world discovered them and realized they were related to volcanic activity no one actually noticed coming. Something strange happened. That underwater eruption created a giant skyscraper-sized volcano. This new underwater volcano turned out to be around 1.5 times the height of One World Trade Center in New York, and almost 10 times bigger than the Statue of Liberty. The area where it appeared had been explored in 2014, but it was almost flat, peaceful, and empty back then. Now, there is an actual volcano nearly 8,500 feet below sea level. The volcano gets its magma from a super profound reservoir located nearly 34 miles underground. It's the deepest reservoir of volcanic magma that we know about. The Earth has layers, and the middle one is kinda chunky. It's very much like peanut caramel filling many chocolates have. Research shows there are probably hunks of oceanic crust deep inside the Earth's liquid mantle. They're stuck there, creating large lumps in something that was supposed to be a smooth layer. Our planet has a rigid outer layer. It includes a hot upper mantle and cracked crust. The hot mantle moves and churns all the time, making the crust at the surface move too. This way, the oceanic crust dives into the depths and makes huge magma plumes go up toward the planet's surface. Scientists even found an ancient piece of the Pacific Ocean hundreds of miles underneath China. Those are the old remains of the Pacific seabed from long ago, and they were pulled downward below Earth's surface into the mantle transition zone. This rocky slab that used to be at the bottom of the ocean is made of the crust and some solid parts of the upper mantle. Most of the volcanic activity on our planet happens where we don't even see it, under the surface of the ocean. About 70% of all volcanic activity happens in the oceans, and mostly in the area of the South Pacific, with over 1,100 volcanoes squeezed into that area. Coastal cliffs, mountain changes, soils, and sediments that line valleys. These are only a small portion of the rocks on our planet. Oceans hide so much more deep down below the Earth's surface. In between the Earth's surface and its core is the mantle. It's a warm, thick layer of rock that moves and flows constantly. Some hundreds of miles below, there's a place where diamonds grow. As they form, they go through high temperatures and pressure, after which they eventually freeze. That way, when they arrive at the surface, scientists can explore their structure, find out how they formed, and understand better what's going on in the depths of our planet. Thanks to diamonds, they realized the mantle was very wet, and it possibly contained much more water than all the oceans on Earth. Our planet is eating up its own oceans. As its tectonic plates move, dive, and go beneath one another, they drag huge amounts of water into the Earth's interior. The water beneath the surface of our planet can help with developing magma and lubricate faults, which actually makes earthquakes more likely to happen. Water is actually stored in the minerals. It gets incorporated into the planet's crust when new oceanic plates form. They go through the process of bending and cracking as they grind under other plates, and huge amounts of water then go deep into the crust and mantle. Scientists research an area that's 18 miles under the surface. They realize these zones pull 3 billion teragrams, which is more than 2 billion pounds. Any ocean is like a whole new world. There are incredible sceneries below the surface, magnificent waterfalls, lakes, and rivers. There are thick layers of salt beneath the seafloor, and rivers and lakes form because seawater goes through those layers and dissolves them, creating something that resembles pools. The dissolved salt makes the surrounding water denser. That water then settles there, which eventually forms underwater lakes or rivers. But there are also mountain chains, trenches, canyons. There's a canyon in the Bering Sea with more than 8,500 feet of vertical relief. This makes the Grand Canyon look way smaller than it is, since the underwater canyon is nearly 2,500 feet deeper. Deep parts of the ocean are really cold. The temperature of the water can be about 40 degrees, but at the bottom, water can get boiling hot. There are hydrothermal vents in the seafloor. Those are the hot springs located at the edges of tectonic plates. The water they release can reach a temperature of up to 750 degrees Fahrenheit, but the pressure at such depths is very intense. So intense, no human being can handle it. Still, it's the pressure that keeps the water from boiling. Ocean depth is on average 2.3 miles. Light waves can still enter at 3,280 feet, even though it's in a very small amount. So all the mysteries hidden below that point remain in total darkness. The actual illuminated part of the ocean goes until 600 feet. Even though the sun gives us light, most of our planet is dark all the time. It's all because of the oceans, covering over 70% of our planet. The loudest sound that came from an ocean, and of the loudest sounds ever recorded, came from an ice quake. It was so loud, researchers picked it up by sensors more than 3,000 miles away. There was a seismic activity that made frozen ground break down. The Antarctic ice sheet is bigger than the continental part of the United States and Mexico together. A big iceberg from Antarctica holds over 20 billion gallons of water, which could make a 5-year water supply for 1 million people. Humans can generally drink sea ice, although we can't drink sea water. As time goes by and the ice ages, the brine trapped between ice crystals drains out. That way, ice becomes fresh enough to consume it. If all the ice sheets and glaciers we have on the Earth melted at the same time, the sea level would rise another 260 feet, which is just a little shorter than the Statue of Liberty, the height of a 26-story building. Clams live long enough to tell us more about oceans past. Ancient mollusks can live for more than 500 years. To learn more about a tree, you can use its rings to see how old it is. To learn how old a mollusk is, you can examine its rings within the shell and tell. This is also how scientists get information about the ocean, climate, and whatsoever. Clams can help take a look at what happened about 1,000 years ago. The Earth doesn't have 4 but 5 oceans now. The new one, called the Southern Ocean, was officially recognized only a few months ago. It borders the Atlantic, Pacific, and Indian Oceans, so scientists couldn't agree if it's really a new ocean or just part of the colder regions of these 3. We don't only divide oceans on maps, each has different conditions for unique marine species. For example, the Southern Ocean has leopard seals, orcas, minke whales, emperor penguins, and other animals that live in cold, icy seas. It's also home to krill, small creatures that look like shrimp and are food for many bigger animals that live there. Life on our planet started about 3.5 billion years ago. I wasn't around then. It's still a mystery how and when exactly, but some theories say life could have first emerged in the depths of the ocean. A few years ago, scientists found microscopic tubes and filaments within rocks formed about 4 billion years ago. These rocks are fragments of ancient oceanic crust. Also, these tiny tubes and filaments are similar to microbes that can still be found on hydrothermal vents in deep parts of the ocean. The idea is these living cells found conditions to stay alive in tiny rocky pores inside the chimneys of those vents, and started the amazing adventure of the evolution of life on our planet.
Oceans cover over 70% of the Earth's surface, so it comes as no surprise that about 50% of the U.S. territory is underwater. We've explored only 5% of oceans. 12 people walked on the moon, but there were only 4 manned descents to the Mariana Trench, the deepest location on Earth. Pressure is the crucial challenge of going deep into the ocean. At bigger depths, temperatures are extremely low, visibility is 0, and the pressure is so intense, it's harder to send people to the bottom of the ocean than to send them into space. You can't see it, but the pressure of the air pushing down on your body in deeper parts is so big, it feels like more than 100 adult elephants or 50 jumbo jets are standing on your head. The pressure is 1,000 times bigger than on the land. Meanwhile, in space, when we pass through the Earth's atmosphere, the pressure drops to 0. We're mapping the planets, but it turns out to be easier than mapping the ocean floor. NASA uses radio waves when exploring space, but this method can't be used for the ocean, since the trillions and trillions of gallons of water get in the way. The Pacific Ocean is becoming smaller, while the Atlantic Ocean is expanding. Many, many years ago, the Atlantic Ocean wasn't even there. It was formed when the North and South American continents separated. Now it's growing bigger at a rate of 2 inches per year, while the Pacific Ocean is shrinking a bit. Oceans even have their own sound, called a bloop. Its quite loud, low frequency, and pretty spooky sound was detected by scientists back in 1997. Some years later, though, other studies revealed that the bloop emanated from an iceberg cracking away from a glacier. There are lakes and rivers in the ocean depths. It's possible because salt water and hydrogen sulfide make a combination that's much denser than the water surrounding it, which is why lakes and rivers might form and flow right inside the ocean. The world's biggest waterfall, called the Denmark Strait Cataract, is underwater too, in the waters between Iceland and Greenland. It's 11,500 feet tall, and its amount of water is almost 2,000 times bigger than the one Niagara Falls has. This underwater waterfall is possible because cold water is much denser than hot water, so cold water drops into the much warmer Irminger Sea. The longest mountain chain is also hidden in the mysterious underwater world. The mid-ocean ridge is almost 40,000 miles long. People studied only about 1% of this ridge. We know less of this chain than we know about the surface of Mars or Venus. Challenger Deep, the southern part of the Mariana Trench. That's a small valley at an extreme depth of a little bit over 36,000 feet. Imagine putting our tallest mountain, Mount Everest, into the Challenger Deep. 1.2 miles would still remain for the mountain's peak to reach the surface of the water. 94% of all living creatures are aquatic, and almost 2/3 of marine life is still not defined. So new species are being discovered all the time, including those spooky ones like the goblin shark, the fangtooth, and the frilled shark. Imagine what more's been waiting for us down there. There are also treasures hidden down below. Oceans have around 20 million tons of gold, but not in a way it can be extracted or mined with any cost-effective methods. It's dispersed all over the seafloor. If we could take it out, each person on the planet would get about 9 pounds of gold. Corals in shallow waters needed to find a way to protect themselves from the sunlight, so they developed some kind of layer that helps them feel good, even when exposed to direct sun rays. Basically, they developed a sort of natural sunscreen. Corals are living creatures. No mouth, eyes, or anything else that could say they're more than a rock, but they are in the category of marine invertebrates. A lot of the oxygen on our planet comes from the ocean. Scientists claim it's about 50 to 80%. The oxygen is produced by marine plants, mostly algae. A tsunami can be up to 100 feet tall, but waves under the surface are even bigger and can reach a height of 800 feet before they collapse. Antarctic fish have proteins inside their bodies that act as some sort of natural antifreeze. These proteins attach to ice crystals and prevent fish from freezing when the water gets too cold. When you place a seashell near your ear, it seems like you hear the sound of waves crashing on some distant beach, like a shell's memories are trapped inside. In reality, the shell amplifies the ambient noise from your current surrounding. There are 1 million volcanoes in the ocean depths, and 80% of eruptions happen underwater. The jellyfish is one of the oldest aquatic creatures, and their ancestors lived 500 to 700 million years ago. That makes them more than twice as old as the first dinosaurs, since they appeared around 240 million years ago. Sharks have also been around for quite a long time, about 400 million years. Fun fact, they don't have bones, but cartilage, the same thing our nose and ears are made of. Their skin is covered in a material that looks more like some sort of teeth than fish scales, dermal denticles. With this, their skin kind of feels like sandpaper, so it helps them be quicker and quieter. The smallest shark, called a dwarf lantern shark, is also one of the tiniest fish in the ocean, since the biggest one ever found was smaller than 8 inches. Lobsters have been around for almost 500 million years. Scientists found fossils of some kind of a huge 7-foot-long lobster, which was one of the biggest animals living at those times. Dolphins are some kind of sleepwalkers, since they sleep with only half of their brain. They close one eye at a time. Sea turtles are quite adaptive animals, and they live on all the continents, except Antarctica. Octopi are incredible marine dwellers. They have blue blood, 3 hearts, and 9 brains. The central one and the other 8 brains are distributed among their 8 arms. They also can regrow an arm in about 100 days. Sea sponges don't have a head, eyes, a mouth, bones, lungs, a heart, or a brain, but they're still living beings. A seahorse is technically a fish, even though it doesn't look like one. This specific animal has no stomach or teeth. Food goes through its digestive systems really fast, so these animals must eat more or less all the time to stay alive. Seahorses can eat more than 3,000 brine shrimp per day. There's a unique spot in the Pacific Ocean where you're farther from all your problems than in any other place on Earth. It's called Point Nemo, and it's about 1,500 miles away from the closest points of land. It's quite hard to get there. First, it's not a bit of land, so you can't actually see it. Second, even the person who discovered it back in 1992 never visited it. The ocean doesn't get struck by lightning as often as the land does, but when this happens, the results can be way worse than on the ground, since water is conductive, so lightning spreads across the ocean really fast. Cold water surrounding your body while swimming may feel refreshing, but that's not a protective layer, and you can still get sunburned. In fact, the water only reflects 10% of UV rays, while the sand reflects an additional 15% of the sun's rays. The temperature in oceans varies. Sometimes you can find water with a temperature of up to 40 degrees Fahrenheit, while there are hydrothermal vents in the seafloor too. They release water that goes up to 750 degrees Fahrenheit. Ouch. There's this thing called the Milky Sea phenomenon, a stunning scene where the water glows with such incredible light that it looks like it's not from our planet. This area is so big, you can see it shining from space, and the mysterious phenomenon usually can be seen in the Indian Ocean. Sometimes, while chilling on a beach, you can see green flashes over the horizon. That happens because the atmosphere bends sunlight when it's passing through, after which it separates the light into different colors. This is in the same way a prism splits the light into what we later see as small rainbows. Black holes have incredibly strong gravitational force pulling objects in. Even light doesn't have a chance to escape it. A similar thing happens with those found in the oceans. Yes, no need to go to space to see one of those. We have them on Earth too. It's just that they don't catch the light, but the water. They are enormous whirlpools, sometimes bigger than whole cities, and they're spinning against the main current, swirling billions of tons of water and everything else on the way. The Baltic Sea anomaly. In 2011, a diving team came down to the bottom of the northern part of the Baltic Sea. They went on a treasure hunt, but what they came upon was a pretty weird object. When they took photos and showed them to others, many believed it was a sunken spaceship of another civilization. Other people thought that some natural causes formed the object, but the metals inside the structure definitely couldn't have been formed naturally. Now, some scientists even believe it was something that appeared way back in the Ice Age. Maybe it was even a meteorite that ended up trapped under ice back then. A maelstrom is a whirlpool, some sort of a powerful rotational current that forms when two currents collide and create a circular vortex. Even fearless Vikings were afraid of maelstroms because those were forces so powerful that they could sink large ships. These whirlpools remain dangerous even today, but luckily, not for big modern ships that are large enough to withstand the power of maelstroms. But a cruise ship that gets into a maelstrom usually faces massive waves that can rock even big vessels from side to side pretty intensely. A maelstrom can be so strong, it can turn into some sort of an underwater black hole. Yep, black holes are not only present in the cold expanse of space, you can find them here on our home planet too, swirling in the oceans. They're similar to those in space, since they're compacted so tightly that nothing they trap can escape. Underwater black holes often span up to 93 miles in diameter. And if you got into one of those, you probably wouldn't even know it. These black holes act like vortices, but because of their size, even professionals can hardly see their boundaries. Here's something relaxing. Next time you go to the beach, pay attention and maybe you'll see an optical phenomenon called the green flash. You can see it shortly after sunset or right before sunrise. It occurs when the sun is almost completely below the horizon, while its rim, the upper one, is still visible. For just a second or two, that upper edge of the sun will appear green. It's because you're looking at the sun through thicker parts of the atmosphere as it's moving down in the sky. As it's dipping below the horizon, light refracts, or bends, in the atmosphere and gets dispersed. Wait for a clear day with no clouds or haze on the horizon to see this phenomenon better. You've been looking forward to a nice swim, only to realize that the water in the ocean is red? Better avoid going in. Florida is known for its red tides. It occurs when the concentration of specific microscopic algae is higher than normal. Thousands of species of algae in marine and fresh waters are mostly harmless to animals and humans. They even help us, since they're an important source of oxygen. But some, like the algae that makes the ocean red, can be extremely dangerous for marine animals, like sea turtles, fish, and seabirds. This kind can grow out of control and produce neurotoxins harmful to humans, especially those who have some respiratory issues. Such people should avoid red tide areas, especially when winds are strong enough to push the algae toward the shore. Volcanoes can spew poisonous gas, ash, and red-hot lava. Those are the most obvious dangers most of us already know about. But submarine volcanoes can be very tricky in their own way. Sometimes, when they're located in shallow waters, they reveal their presence by blasting debris of rock and steam high above the surface. Since submarine volcanoes are surrounded by an unlimited supply of water, they can behave differently from those on land. When they erupt, seawater gets into active submarine vents. Lava can be spreading across a shallow sea floor, or sometimes even flowing into the sea from land volcanoes. When in water, it may cool down so quickly that it shatters into rubble and sand. So, there are large amounts of volcanic debris left there. You know those popular black sand beaches in Hawaii? That's how they formed. Hot lava and powerful eruptions certainly don't sound safe, but submarine volcanoes in deeper waters are equally dangerous. Even though they're not necessarily erupting, they produce pockets of bubbles. These bubbles reduce the density of the surrounding waters, which can even sink ships. The worst thing is that when you look at the surface of the ocean, you can't understand something's wrong. But at the same time, tiny bubbles are there, causing ships to lose buoyancy, and with very little warning. A cross sea is a rare phenomenon, beautiful to observe, but also very dangerous. It's when you see square waves, which are more common in shallow parts of the ocean. That's something you can often see in France or on certain beaches of Tel Aviv, but it can also happen in many coastal areas across the world. A cross sea occurs when two wave patterns travel at oblique angles. They form this checkerboard-like pattern. It mostly happens when two swells meet, or when a swell pushes waves in one direction, while a strong wind pushes them in another. These square waves can be dangerous for swimmers and boaters. The waves produced by strong ocean currents can be pretty unpredictable and tall, sometimes up to almost 10 feet. This phenomenon is sometimes called white walls. These waves can be so powerful that they can turn over even big boats. If you fill a clear glass with some ocean water and take a closer look, you'll see it's full of very small particles. Seawater contains dissolved salts, fats, algae, proteins, detergents, and other bits of artificial and organic matter. If you shake that glass, you'll see tiny bubbles forming on its surface. That's how sea foam forms when waves and winds agitate the ocean. When you see thick sea foam, algal blooms might have caused it. When big blooms of algae fall apart in the sea, large amounts of that matter move in the direction of dry land. Most kinds of sea foam aren't dangerous to humans, but when blooms of algae fall apart, it can have a negative impact on both the environment and people. For example, when sea foam bubbles pop, the toxins they contain get released into the air, and they can irritate your eyes or cause some other health issues. You can see a tidal bore in the areas where a river empties into a sea or an ocean. It's a powerful tide that goes against the current and pushes up the river. A tidal bore falls into a category of something called the surge, which is a sudden change in depth. A tidal bore is a positive surge, which means it pushes up a river, making it much deeper. A negative surge is when the river suddenly becomes very shallow. You won't see tidal bores everywhere. The river must be fairly shallow with a narrow outlet to the sea. The place where the sea and the river meet must be flat and wide. Also, the area between low and high tide must be at least 20 feet across. Of course, there are some exceptions, like the Amazon River, the world's largest one. The mouth of the Amazon is not narrow, but the river experiences tidal bores. That's because its mouth is shallow and has many sandbars and low-lying islands. The tidal bore is so strong there that the river doesn't even have a delta. Its sediment goes directly into the Atlantic Ocean, where fast-moving currents take it away. A tidal bore is often unpredictable and can be extremely rough. In many cases, it changes the color of the river from greenish or blue to brown. It can damage vegetation or even tear trees out of the ground. So, recreation sports like kayaking and river surfing can be hazardous in these areas. Even if you just want to take a look at a tidal bore, be careful. Tidal waves can sweep over lookout points and drag whatever or whoever is there into the churning river. Back when it was built, the Titanic was one of the largest and most luxurious passenger ships, with high-class features like a grand staircase, a swimming pool, and a gymnasium. People thought it to be unsinkable because of its advanced safety devices. Its tragic sinking on its maiden voyage in 1912 proved it wasn't at all the case. It wasn't until 1985 that the Titanic's wreck was finally rediscovered using state-of-the-art sonar technology. Ever since, thousands of items have been recovered from the Titanic, many of them being put on display or sold for auction. Things like jewelry, a life jacket, a menu from the ship's restaurant, or even a sample square of carpet from the first-class stateroom have all baffled the public and told stories of the many on-board people. Scientists have even tried to come up with strategies to get the Titanic back up. Not because they want to put it up for display, but so it can be properly studied, and more importantly, to stop it from getting more and more damaged at the bottom of the ocean. Some have suggested filling the wreck with ping-pong balls to make it float, while others even considered injecting it with 198,000 tons of Vaseline. Another creative solution was proposed, the idea of using a giant claw or scoop to lift the Titanic. Nobody came up with this device. Using 500,000 tons of liquid nitrogen to trap it in an iceberg that would float to the surface was also considered, but all these potential strategies had to be eventually let go, since the Titanic is way too fragile to ever be recovered. As the Titanic's iconic bow railings are in danger of collapsing, metal-eating bacteria continue to chew away at the ocean liner's wreckage. An undersea exploration company plans to gather data about the ship's deterioration in annual expeditions. They hope this will help them learn more about the Titanic, and also more about the ecosystem that shipwrecks create. The over 100-year-old ocean liner is also being damaged by deep-sea currents daily. Some experts predict that the ship could disappear in a few decades due to holes in its hull. The deck that passengers crowded on as the ship sank has caved in. The gymnasium near the grand staircase has also fallen in, and a 2019 expedition found that the captain's bathtub, which became visible after the outer wall of the captain's cabin fell away, is no longer there. Those annual expeditions also gather data about the creatures living at the site, including crabs and corals. Surprisingly, many species have only been seen there at the Titanic wreck, so scientists are curious to find out more about them. The most famous out of all these creatures is the Halomonas titanicae. It's a bacteria, and it was discovered on the wreckage of the Titanic. What's interesting about this creature is that it's able to thrive in extremely salty environments. It's also been resistant to several antibiotics, unlike other types of bacteria. It's probably because of this super bacteria that the deterioration of the ship's iron hull happened so fast. The expedition will also look at the debris field and its artifacts. On the site, there are still traces of little personal items like clothes and luggage. One of the most interesting stories about Titanic artifacts is that of the passengers' shoes. Most of the Titanic items that have been lost at sea deteriorated or disappeared completely. But not the shoes. They seem to be able to resist the harsh conditions. On top of that, the leather in most shoes is perfectly preserved, probably because of tannin, a substance used in the tanning process of leather. It helped the shoes resist the damaging bacteria found underwater. All this exploring might have gotten you all excited. If that's the case, I have some good news to share. You might even be able to join the expeditions. To personally explore the Titanic, you have to plan ahead and apply to be a mission specialist with OceanGate, the company responsible for the journey. However, this experience does come with a high price tag of $250,000. Despite the cost, this once-in-a-lifetime experience is in high demand because of the limited spots available. If you can afford the exploration, you will have the chance to collaborate with renowned specialists in marine biology, oceanography, the Titanic, DNA, and the deep ocean. Accommodations and meals on the dive support vessel are also included, as well as training and guidance from specialists before and during the mission. Lastly, you don't even need to bring your own gear, as the expedition equipment is included as well. Sure, ships have evolved and modernized over the years, and these days we have technology that is way better than that available on the Titanic. But this ship remains an amazing piece of history because of its many unusual features, like the fact that the Titanic's whistle was loud enough to be heard over 11 miles away, or the fact that the ship's hull was painted with a special mixture of red lead and linseed oil, which was believed to be effective in preventing the growth of seaweed and other marine organisms. However, despite popular belief, the ship's iconic fourth smokestack was not functional and was only used for ventilation and aesthetics. Probably one of its biggest flaws was its number of lifeboats. Despite its size and luxury, the Titanic only had 20 lifeboats on board, which were not enough to save all of its passengers and crew once it hit the iceberg. The Titanic may be the most famous shipwreck, but it's not the only one. The fleet of Kublai Khan tells a similar story. This one was a large naval force commissioned by the Mongol ruler Kublai Khan in the 13th century. The fleet was intended to travel to Japan and establish the Mongols as powerful rulers in the region. However, in 1281, the fleet was supposedly caught in bad weather and was seriously damaged, with many ships being destroyed. Legend has it that the fleet was torn down by a massive typhoon that came to be known as the kamikaze, or divine wind. This strong storm was believed to have been sent by the higher spirits to protect Japan from the Mongols. The truth about its disappearance remains a mystery to this day. However, the wreckage of the fleet, or parts of it, appears to have been discovered in the 1980s by Asian archaeologists. They dug across the site and studied the remains of the ships at a location near Imari Bay. The shipwreck is, to this day, considered to be an important archaeological discovery. That's because it informed us how well prepared the Mongols were back in the day in terms of their ships. Another tragic story is that of the RMS Empress of Ireland. This was a British passenger ship that operated until May of 1914. This is when the ship was sailing from Quebec City to Liverpool, but it ran into the Norwegian collier SS Storstad in the fog off the coast of Rimouski, Quebec. The collision caused a large hole in the side of the Empress of Ireland, and the ship began to quickly take on water and sink. The crew and passengers were caught off guard, and many were unable to evacuate in time. In total, 1,012 people were lost in the disaster, making it one of the worst maritime collisions in Canadian history. Rescue efforts were hampered by poor visibility, and the fact that many of the lifeboats were damaged or unusable. Only 465 people survived the sinking, and many of them were rescued by the Storstad, which had remained in the area despite its damage. The sinking of the Empress of Ireland was a national tragedy in Canada, and it led to changes in maritime safety regulations and the establishment of a Coast Guard. The ship still lies at the bottom of the St. Lawrence River, where it has become a popular dive site for enthusiasts. Imagine a world where instead of water, the oceans are made of methane. Yeah, that's right. Instead of swimming in H2O, you'd be paddling around in CH4. It's like Mother Nature's version of a fizzy drink. Such oceans actually exist on one of Saturn's moons called Titan. In fact, the methane and ethane on Titan play a similar role to the water on Earth. They cycle through the atmosphere and form clouds that eventually rain down onto the surface. They were discovered by the Cassini-Huygens space probe, and apparently, our entire planet's oil reserves could fit in one of Titan's puddles. Even the desert sand dunes on Titan have more organics than all of Earth's coal reserves. Who knew that Titan was the place to go if you're ever in need of fuel for your car? Now, obviously, there are some things that distinguish methane lakes from our water ones. First, the temperature on Titan is around negative 290 degrees Fahrenheit. It's like taking a dip in a giant glass of liquid nitrogen. Not exactly ideal for a beach day, is it? Methane is also less dense than water, so if you were to go swimming in such an ocean, you'd float like a balloon. On the bright side, it would make doing the backstroke a lot easier. Next, while water waves can be pretty majestic, unfortunately, we can't ride any on Titan. Cassini didn't detect any big waves there. Maybe it's due to low seasonal winds, or the fact that some of the lakes are much smaller than Earth's lakes, but we don't know for sure. Also, I know what you're thinking. If the oceans are made of methane, could you set them on fire? Technically, yes. Methane is a highly flammable gas, so if you were to light a match in a methane ocean, you'd get a pretty impressive but dangerous blaze. So, given all these differences, the question arises, what would a planet with such oceans look like? Well, we can make some guesses by looking at Titan. First of all, its atmosphere, composed primarily of methane, would be incredibly thick. Titan's atmosphere reaches nearly 370 miles into space, and the atmospheric pressure there is 60% greater than Earth's. So, if you ever wanted to experience the feeling of swimming super deep in the ocean, now's your chance. Also, methane is a powerful greenhouse gas that traps the sun's heat really well. That's why our planet would warm up faster than a sauna. You may ask, why is it so cold on Titan then? This is because this moon is very far from the sun, and light doesn't reach it well. But if we place our planet somewhere in the middle, then the temperature may even be quite comfortable. Actually, methane oceans on a planet could really spice up the climate. The planet would be a breeding ground for methane clouds. Just like on Titan, it could form an orange-colored haze, or smog, that would make our planet look like a real mystery. It would be difficult to see us from space without some special telescopes. And let's not forget about methane storms. They would also occasionally drench the surface, so remember to bring your umbrella. But hey, at least the heavy carbon-rich compounds would make for some pretty sweet dune fields. And finally, the most important difference. While water oceans on Earth are teeming with all sorts of creatures, we're not sure if there's any life in methane oceans on Titan. If there is, they'd have to be pretty tough to survive in such extreme conditions. So, if life on such a planet exists, it would be very different from what we're used to seeing on Earth. For example, microbes might be able to handle it. These tiny resilient creatures can survive in a wide range of environments, including extreme ones. So it's possible that microbial life could exist in methane oceans. And what about us and animals? Well, scientist Robert Zubrin thinks that Titan might be the perfect place for humans to colonize in our solar system. According to him, this little moon has everything we need to survive and thrive. And if it's possible on that moon, then it could work with a planet too. For starters, we'd need some oxygen to breathe. We could use nitrogen and methane in the atmosphere to create breathable air and rocket fuel. We could also use these elements to make some fertilizers and grow plants. Next up, we'd need water. Since the oceans are made of methane, we can't exactly drink them. We'd need to find or create sources of water. Scientists believe that it actually may be hidden below the surface on Titan, together with some ammonia. We could use it to drink or create even more oxygen. So, with all of these resources, we could create a self-sustaining colony even in a place with methane oceans. Piece of cake! Although, there are always alternatives. Maybe we could become methane breathers, evolve into organisms that use methane instead of oxygen. For example, we could get some large lungs because we'd have to inhale a much larger volume of air, since methane is less dense than oxygen. But this is pure sci-fi. Methane oceans are not the only unusual oceans in space. It turns out that seas on diamond planets may be even weirder. Take WASP 12b, for example. This exoplanet, located about 1,200 light-years away, might have oceans of tar. That's right, tar. The planet has more carbon than oxygen, which means its crust is probably made of things like diamond and graphite, instead of your average silica-based minerals like granite. Imagine stepping on this planet, and the first thing you notice is that the beaches are made up of black goo. It's like stepping into a nightmare, where you're trapped in quicksand made of sticky sludge. So forget about the sandy beaches and crystal clear water you're used to. Here, you'll be living the pitch life. Your swimwear will be replaced with hazmat suits, and you'll need a sturdy pair of boots to walk on the sticky surface. But in reality, WASP 12b is not the place to look for geology of any kind. It's simply too hot for anything to survive, let alone thrive. But there might be smaller, similar exoplanets where we could potentially live. Now, you might be thinking, tar oceans? That's crazy talk. But did you know that there's a 246-foot deep lake of natural asphalt here on Earth? It's called Pitch Lake, and it's located in Trinidad. It's formed when oil is forced to the surface, and the lighter components evaporate, leaving the thicker, heavier pitch behind. And guess what? This lake is home to a thriving ecosystem of microbes. So if you want to live on such a planet, at least you won't be alone. You'll have plenty of company in bacteria, fungi that love to feast on carbon found in asphalt, and archaea that live on methane. And finally, there are oceans of molten rock. That's right. Imagine a world where the floor is lava isn't just a game, but a reality. Welcome to 55 Cancri E, a planet so hot that the entire hemisphere facing its star is covered in magma. It's like a scene out of a heavy metal album cover. But don't worry, the other side of the planet is slightly cooler, so you can at least step off the lava and catch your breath. If you're feeling adventurous, you could always hop over to Koro T7b, another super Earth where the lava ocean is just as scorching. But this time, the night side doesn't offer much respite either. It's still seeing constant volcanic eruptions, like some sort of fireworks show. Scientists are scratching their heads trying to explain why these planets are so hot, and why they haven't cooled down yet. Maybe they're just really good at retaining heat, or maybe they just have a bad temperament. Either way, it's probably best to stick to playing the floor is lava on solid ground, and leave the real lava planets to someone else. All this diversity of oceans shows us that the universe is always full of surprises. It never ceases to amaze us with its creativity. Although these oceans are not suitable for human exploration yet, they challenge our understanding of what could exist beyond our world. So, let's continue to explore.
Oh wow, there's a hole in the bottom of the ocean. It seems that the ocean has a leak. But it's not like a leak you would expect, where water is flowing out. It's more like a spring since water is flowing in, not out. This unique leak is something we know as Pythia's oasis. A grad student was the one who accidentally discovered it. He noticed bubbles that were rising to the surface. Normally, bubbles in the ocean tell us there might be some hydrothermal vents, which are hotspots for some pretty cool things. These vents are actually like hot springs on the seafloor, but instead of bubbling with warm water, they release a fluid that has been superheated in the crust of our planet. When seawater seeps into these cracks and travels deep into the crust, it comes into contact with the extremely hot mantle. This heats seawater to very high temperatures, and as it moves back up towards the surface, it carries dissolved gases and minerals. When the hot fluid shoots out of the vents, it mixes with the surrounding seawater and quickly cools down. Just a short distance away from the vent, the temperature can drop to a comfortable 68 degrees Fahrenheit or so, which is, as it seems, exactly what some creatures like. And there are some real weirdos living down there in the darkness, like ghostly fish, giant red-tipped tube worms, and a unique type of shrimp with eyes on their back. And some of them, like tube worms and bacteria, rely on the chemicals and minerals released by the vents to survive in harsh conditions. But in this case, the bubbling water didn't come from a hydrothermal vent. It was there because of a spring, and that's a bit more concerning. You see, the water in this reservoir needs to stay where it is. If too much of it seeps out, there could be some serious consequences, especially for the surrounding area. You can see this unusual leak along the Cascadia subduction zone, which is a massive fault line off the Pacific Northwest coast. It's a place where two pretty big plates that make up Earth's crust come together and slide along each other. The water from Pythia's oasis kinda acts as a lubricant between these plates. You can think of the fault zone as an air hockey table. When the fluid pressure is high, it's like you've turned the air on. That means the friction between the plates is reduced, which allows the plates to move. But if the fluid pressure is lower, the two plates can lock together, which then leads to the buildup of stress. Not that they'll feel bad. In the context of tectonic plates, stress is some pressure or force that can cause deformation. And if this stress starts to build up, at some point, it's gotta go somewhere. When it's too much, it can trigger earthquakes and most likely, not small ones. For example, a release of stress in the Cascadia subduction zone could lead to a magnitude 9 earthquake. For comparison, the biggest earthquake we've ever recorded happened in Chile in 1960, and it had a magnitude of 9.5. The damage was enormous. So we hope the water will stay in its reservoir and keep maintaining the delicate balance between the tectonic plates. We've explored only 5% of the ocean. Who knows how many cool things are there at the bottom, waiting to be found? For example, check out these mysterious holes scientists have stumbled upon in the depths of the Atlantic Ocean, near the Azores. They're neatly aligned and are about 4 inches apart, or in some cases, even several feet. They resemble punctures left by a sewing machine. Some think these holes could have a biological origin. For instance, some fish may have made them while walking along the seafloor. Others believe we could be looking at something that's human-made, maybe left by a spiked tire. Of course, such holes are perfect for making up stories about creatures from other planets who allegedly made them. Or maybe even legendary monsters, like that one from Loch Ness. It's definitely hard to explain such symmetry of the holes, but one deep-sea biologist offered a pretty good explanation. He said there could be an animal burrowing beneath the sediment, and from time to time, it could make little chimneys just to get access to clean water circulation in its small burrow. I mean, there are sediment piles around the opening of each hole, and they do support the idea that something pushed the soil from below. But there's still no proof these holes are actually connected beneath the surface. And there are also a lot of things hidden at the bottom of the oceans and seas that ancient civilizations left us. For instance, archaeologists made a really cool discovery off the southern coast of Croatia, a road hidden under layers of sea mud that's 7,000 years old. They found the ancient road at the sunken Neolithic site of Solin. The site of Solin was a human-made island in ancient times, and an archaeologist discovered it 2 years ago. He was studying satellite images of the area around Korčula, one of the beautiful Croatian islands. When he realized there could be something interesting at the bottom of the sea, he dove into the water with his colleague. And under the surface of the Adriatic Sea, which is part of the Mediterranean Sea, at a depth of 13 to 16 feet, they found stone walls that were most likely part of some ancient settlement. The landmass where people built the settlement was separated from the main island by a narrow stretch of land. Luckily, this area is protected from big waves by the surrounding islands, so the site remained relatively well preserved. It's now hidden beneath the surface of the sea and covered in mud. But it's so exciting to imagine how people walked on that road nearly 7,000 years ago, visiting nearby settlements. If you want to see the weirdest creatures, you can always head to the bottom of the sea. Actually, scientists have determined there could be more than 30 potentially new species at the bottom of the Pacific Ocean. They've collected them using their remote-controlled vehicle. That's a big step because until recently, they could only study such creatures through photographs. I'm talking about segmented worms, different types of coral, some invertebrates similar to centipedes, and many others. But there are also many old freaky creatures that we already know about that look like they came from sci-fi movies. Red octopus, blobfish, okay, this one kinda looks normal until you raise it to the surface, the goblin shark, Sloane's viperfish, zombie worms. Ugh, yeah, I hear ya. Let's move on. The seafloor hides things from space too. There are traces of rare forms of plutonium and iron at the bottom of the Pacific Ocean. And what's awesome is that all this has come from space. These radioactive materials probably formed during some kind of cataclysmic event in space and eventually made their way out to our beautiful home planet. And this extraterrestrial debris most likely appeared on Earth within the past 10 million years. After it fell to the Pacific Ocean and settled at a depth of almost a mile, it became part of all those layers of rock down there. Plutonium is especially exciting for scientists. I mean, only tiny amounts of it have been found, hundreds of atoms maybe. But it's still remarkable because these atoms are created by exploding stars. Things like this can help us better understand how the universe produces elements heavier than iron, like plutonium, gold, uranium, and platinum. We're still not sure about the origins of these elements. For a long time, scientists believed that supernovae, which is when a star comes to its end in a fabulous explosion, were responsible for creating these heavy elements. But it seems it's not just that. Some other cosmic events, such as the collision of neutron stars, which are super dense collapsed stars, or some rare types of supernovae, could also be involved. Whoa, let me get my popcorn!